Okay, this lesson is lesson 1.4, and we are learning how to simplify expressions, which is kind of mean the same thing as combining like terms. Okay, that's often how we refer to it, combining like terms. But first, what is a term? Okay, what is a term? Terms are broken apart by plus or minus signs. So if you're looking at what we're starting with here at the top, I'm going to circle this. We have a whole bunch of terms up here. 7x is a term, 3, 5x, 8, 4x, and 1 are all their own terms. Okay, I have 1, 2, 3, 4, 5, 6 terms up here. They are all separated by plus or a minus sign. So a plus or a minus sign is what breaks apart our terms. It's how we leave one term and start a new one. We're broken apart by plus and minus signs. Then we need to be able to classify or name what kind of terms that we have. So we have two major types of terms, which is what this branching off is showing. Okay, two different types. We have variable terms, which are terms which have a variable, which have a letter. So up here above, I'll circle those in red. Our variable terms all have an x up here, and it could be any letter to be a variable term. We have 7x, negative 5x, and the sign directly in front of the term belongs to it. So this negative was right in front or to the left of 5x, so this is a negative 5x. And positive 4x. I'll write those down in this box. So 7x, negative 5x, and 4x are all the variable terms. Now let's keep going down with this. What are coefficients? Every variable term has a coefficient, which represents the number next to or right in front of the variable. So our coefficients here would then be 7 is in front of x, so 7 is a coefficient. Negative 5 was in front of x, so negative 5 was the coefficient there. And 4 was in front of our last x variable term, so 4 was a coefficient. So when we say coefficient, we're talking about the number in front or attached to the variable, okay, in the front, big number. Okay, so the other types of terms we have that are not variable terms are called constant terms. So here we are. A constant is a term that does not have a variable. It's just a number. Just a number. No letters. Okay, no letters. Let's write that down. So our constant terms, I'm going to circle them in green at the top, would be positive 3, positive 8, and negative 1. None of those terms had any letters attached to them, so we call them constants. And it's really important to just know the terminology. It helps if you know what we're referring to. So looking down, it says you can simplify algebraic expressions by combining like terms. That's what we wrote above. That means to combine common variable terms and common constant terms. To put terms together, their variables have to match. So x terms can go with x terms, y terms could go with y terms, and constants can go with constants. Okay, and if we had a's, they'd go with a. Just match your letters up. If they have exponents, then their exponents would need to match as well. So it kind of reminds me of like being in like elementary school or primary school where you had to match things. If they match, you can count how many you get when you put them together. So on number, or this problem, 7x plus 3 minus 5x plus 8 plus 4x minus 1, that problem from above, we want to know which terms actually go together. Well, all of my variable terms can go together because they all have an x. So 7x, negative 5x, and positive 4x. We're going to put all of those together. And you could just type it into your calculator as you see it. 7 minus 5 plus 4. We don't put the x's into our calculator because our calculator doesn't do letters. But the thing that I know is because they all have that x that comes after the number, whatever 7 minus 5 plus 4, whatever their coefficients add to, which is 6, we're going to put that down. Okay, they made 6, and then you just put that same variable after it. So that became 6x. And then we have another type of terms we talked about was we had constant terms. So all my constants can go together, and we need to pay attention to what their signs are. We had a positive 3, a positive 8, and a negative 1. And again, in my calculator, or I could do it in my head, I could do it mentally. I could say 3 plus 8 is 11, but 11 minus 1 is a positive 10, and because it was a positive 10, we are going to say plus 10. So this simplifies to 6x plus 10. Now we're going to continue simplifying or combining like terms throughout the rest of the lesson and really paying attention to who matches up with whom and what their signs are, and paying attention to the signs and how they play a role in simplifying things down. Okay, example 1. On each of these, we're simplifying the expression. Now remember, if it's a variable expression, if it's something that has a letter, to be a like term to it, it has to have the same variable. So if I have 3x, to go with a 3x, something else would also have to have x attached to it, and 6x does. So these two would be considered like terms. We can add their front numbers together because they both have that x. That's what's allowing us to put their front numbers together. So we add 3 and 6 to get 9, and then we have to put that variable afterwards. It's almost like a label. Okay, I said I have 3 x's and I'm adding 6 x's to it. How many x's do I have now? 9 x's. Okay, it's just a way of labeling what we're dealing with. On number 2, I have 9a, take away 10a. These are like terms as well because they both have a that comes after their coefficient. So again, because these are like terms, we can put their coefficients or their front numbers together. 9 minus 10 is -1, and we put that variable afterward. So you can write it as -1a or -a, and those mean the same thing. A lot of times in algebra, if our coefficient is 1 or -1, or if our exponent is 1, it's implied. We do not have to write the 1, but you can if it makes you feel really happy inside. And I do it both ways because I know people like it both ways. Okay, number 3. We have 7m minus 5m minus 6. Now, not all of these are like terms because not all of them have the m that comes after the big number. My like terms are 7m can go with the -5m, but -6, I'm going to show it in a different color, it is not a like term to 7m and 5m because it doesn't have the m. So again, by color coding this, I'm trying to hope to show you which terms can be grouped together. We can only put together 7m minus 5m as the like terms, which means add their coefficients. 7 minus 5 is 2, and make sure you put that m after it. Now I only had one constant, one regular number, which was -6. It can't combine with anything else, so we bring it down and write it after the 2m. Number 4. Okay, what are my like terms? I have 9 minus 6w plus 5. Well, I'm looking at my variable terms. Oh, I didn't like that. The only thing with a variable is w, and that's my -6w. So nothing else has a w. But I do have 2 constants, 2 regular numbers. I have a 9 and a +5. So again, I'm color coding this or showing in green that the constants. I have 2 constants that can be combined. 9 and a +5 make +14, so I write that down underneath. You could even cross them off afterwards to show that you used it. The only thing we haven't used is -6w, and I don't have any other w's to combine it with, so we bring it down. And 14 cannot go with the -6w because 14 does not have a w. They're not like terms. So this is as simple as we can make this part of the problem. Okay, on number 5, my expression is 7p minus 1 minus 9p plus 5. Remember, to be like terms, they have to have the same type of letter. Same letter with the same kind of exponent if they have exponents. So 7p could only go with something else that has a p, which is our -9p. Notice I kept that negative sign with it. And then constants go together, regular numbers. So that would be my -1 and my +5. So I'm going to put together my p's. If I have 7 p's and I minus or take away 9 p's, I'm left with -2 p's. Okay, I've used up my p's. Now let's put together our constants. I'm putting together a -1 and a +5, and that makes a +4. And again, I cannot put this together and say 2p. This right here, negative 2p plus 4 is the answer because a 2p or negative 2p cannot go with something that's just another number. They are not like terms. Okay, number 6. My expression is 5h minus 6 minus 8 plus 7h. So anything that just has a regular h after it are considered like terms. So that would be my 5h and my positive 7h. Regular numbers, constants, will be like terms. So that's negative 6 and negative 8. Put them together with the signs they're showing, those big front numbers. So my 5h's and my 7h's, I'm adding 5 and a positive 7 here to make 12h's. My constants, negative 6 and negative 8. Again, if you weren't sure because you don't like dealing with negatives, just type it into your calculator exactly as I circled it. Negative 6, subtract 8, and you get negative 14. And write that afterwards. And again, this is a 12h. It can't go with a negative 14 because they would either both have to be regular numbers or both have the h to be combined. And they don't. They're different. So they stay separate. On number 7, okay, we have 5x plus 7y minus x plus 2y plus 3x. So we have two different variables that are being used in this example now. Anything with an x can go with other x's, and our y terms go with other y terms. So that puts us at, not that again, I forgot to change it to highlighter. 5x would go with negative 1x and positive 3x. 7y is going to go with positive 2y. So notice I've accounted for everything. I have 1, 2, 3 x terms that I can put together. What is the coefficient of this negative x? If it doesn't have a number, it's a 1 in there. That's a negative 1. So we have 5 minus 1 is 4 plus 3 is 7 x's. Okay, we've used up all of our x's. You can cross them off. Now moving to our y's, I have a positive 7y's plus another 2y's. 7 plus 2 make 9y. And again, we have to have 7x separate from 9y. We can't put them together to get 16xy's. They are not like terms. And algebra, that might not seem very fair, but when we're adding and subtracting, we cannot put things like this together. Adding and subtracting does not have that power. Okay, finishing up on this page or slide with number 8, we have 26a plus 2b minus 4a plus 10b. So a terms go with a terms, and b terms go with b terms. So 26a goes with negative 4a. 2b, or not to be, just kidding, goes with, I have to say that every time, goes with positive 10b. I'm so funny. Okay, 26a's, if we take away 4a's because it had a minus sign in front of it, so we do have to minus it, we get 22a. Done with our a's. In red, I have 2b plus 10 b's. How many b's do I have in all? I have 12 b's. So our answer is 22a plus 12b. So all of the variable terms that we've had up until this point have not had exponents attached to them, which are those little numbers that come just to the right of the variable. We haven't had exponents yet. So when it comes to our variables having exponents, let's read what it says up here above. It says terms with the same exponents or combination of variables and exponents are considered like terms. When combining, be sure not to change their exponents. So in other words, it's saying like if you have an x squared, it could only go with another x squared. Okay, like we have on number 9. But an x squared cannot be combined with like an x to the 5th. We can't do that with addition. Those would be separate terms. We can't, that does not equal x to the 7th. Okay, that's bad. Bad. Don't ever do that. We only multiply them. We can't add. Okay, if we have a term that has an AB, okay, and we try to put it with an AC, again, that can't be done. They are not like terms. They have to have the same exact variable with the same exponents or the same combination of variables. Like an AB can only go with another AB. Yes, we can do that and make it 2AB. Okay, an AC could only go with an AC, and so forth. So we have to make sure all those parts of the variables we're using are matching, and then we add not their exponents, but only their coefficients, their front numbers. So for example, on number 9, when we do 5x squared plus 7x squared, they are like terms because they both have x squared, okay? Now notice if we had said 5x plus 7x, we'd get 12x. We wouldn't have changed x's exponent. It's the same thing here. 5 plus 7 is 12. We keep its variable the same. It stays x squared. We would not say 12x to the 4th. No. Okay, do not change the exponent. It's more like that what comes after the number, okay, those variables is more like a label, and we're not changing it. X squared, them both having the x squared is what gave us the power to put their coefficients together. Okay, so let's look at number 10. I have negative 15n to the 5th plus 4n to the 5th. They both have n to the 5th power. That means that we can put their coefficients together. Negative 15 and positive 4 makes negative 11, but it's still n to the 5th power that we put behind. We don't change 5 and 5, add those together to make 10. No way, Jose. Okay, not negative 11 n to the 10th power. Nope. That n to the 5th stays the same. Just change coefficients. So on number 11, we have 8c cubed. I keep doing that. And minus 7c cubed. That's a like term because it has c cubed. Plus 16c cubed. They're all like terms. So the part that's c cubed, not going to change. What's going to change is what their coefficients, the front numbers, add to. 8 minus 7 is 1. 1 plus 16 is 17. So I could put that in front of the c cubed. You can write down that variable first if it helps you remember not to change it. So on number 12, I have 8k squared minus k minus 5k plus 7 minus 2k squareds. So we've got k squared terms, k and constants. So let's watch what happens here. Something that's a k squared can only go with something else that has a k squared, which is this negative 2k squareds. My regular k terms with no exponents would be negative k minus 5k. They're allowed to go together because they both are the same. They're plain k's. They don't have exponents. And then my positive 7, it's on its own. It's the only constant there. Now can you see how I use 3 different colors here? Okay, we have 3 different colors. That means that in my answer, I'm going to have 3 different terms in my answer. Okay, I'm going to start with my k squareds. 8k squared minus 2k squared. 8 minus 2 is 6. It stays k squared. Okay, I can cross them off so I don't forget that I've already used them. In red, I have negative k minus 5k. In other words, negative 1 minus 5 is negative 6k. So I've used up my k's. They're different than k squareds. And last, I have a positive 7 who doesn't combine with anybody else. And so we stay 6k squared minus 6k plus 7. Okay, our last 4 examples. On number 13, we have negative 4a squared b plus 7 plus 10a squared b. So notice our variable terms, we have negative 4a squared b. It can only go with something else that has an a squared b, and that's positive 10a squared b. Those are like terms. My plus 7 in here, that's a constant. It doesn't have anybody to combine with, so it's going to be on its own. So the only things I can put together here for my like terms are their coefficients. Negative 4 and positive 10 make positive 6. And we leave what comes after that the same. No changes to those variables. A squared b. Okay, those have been used. And then I have this plus 7 with nobody to combine with, so we just bring it down and we're done. Okay, number 14. We have x squared plus 2xy minus 7xy plus 4y squared. Okay, we've got an x squared. It can only go with another x squared term, but I do not have any, so it's by itself. I have a positive 2xy that can go with a negative 7xy because they are both xy terms. And then my 4y squared, y squared is different than x squared. So that's why I showed it in a different color. My x squared and my 4y squared cannot combine. Even though they're both squared, they're different variables, different letters, so they can't go together. So we're going to have x squared that comes down by itself, no one to combine with. my positive 2xy minus 7xy. Positive 2 minus 7 is negative 5, and then we put xy after it. And last we have positive 4y squared. Because it had no one to combine with, we just bring it down. Okay, number 15, we have a squared plus 7ab minus 10ab plus 1b squared. So we have an a squared here that would only go with another a squared, but we do not have one, so it's by itself. We have positive 7ab that can go with another ab term, so negative 10ab. And then b squared is by itself. Again, a squared and b squared, they're not the same letter, even though they're squared. They're different terms, so we keep them separate. So we bring down a squared, okay, a squared, and then my 7 minus 10 makes negative 3, and then it stays ab, and then we bring down plus b squared. Okay, if it doesn't have anybody to combine with, we just bring it down as it is. And last we have number 16. This is our last example. I have 4x squared minus 7 plus 2x minus 3x squared plus 8x minus 6. So starting left to right, if I have 4x squared, it could go with another x squared term, which would be negative 3x squared. Negative 7 is a constant, just a regular number. I have one other constant, negative 6. And then I have x terms, okay? An x that doesn't have an exponent. Oops. So that would be positive 2x would go with positive 8x. And again, they are like terms because they both were x's that didn't have any exponents. So putting together my x squareds, 4x squared minus 3x squared leaves me with 1x squared, which we could write as just x squared, or you could put the 1 in front. It means the same thing either way. And then I have my x terms. I have 2x's plus 8x's is positive 10x's. And then I have my constants. Negative 7 and negative 6 would combine to make negative 13. And this is done. Again, 3 separate terms. X squareds can't go with x's, which can't go with constants. So really pay attention to the types of letters. They have to be the same exact letter with the same exact exponents to be allowed to combine. And then when we do combine variable terms, we don't change exponents, we just change the coefficients, which are the front numbers.